a show about ZK products where we break them down with rich flavors and sweet insights. I'm Queenie, and I'll be co hosting this episode with Omer. Today, we're thrilled to be joined by Esli, Head of Product and Ecosystem at Marlin Protocol, building scalable coprocessor for decentralized compute. Asli, it's great to have you on the show.
Thank you, Queenie. It's fun to be on the show. I've heard some of your podcasts; they are pretty insightful. Uh, I was, I was, I just heard your the previous one, wherein you had one with Ishmael from Lagrange. That was pretty insightful. You spoke about whole deep proof. I think that is pretty dope. What you guys have been doing. So yeah, happy to be
Thank
here.
you. Yeah, thanks for the kind words. We're glad to hear that. So, as a first question, we'd love to hear how you got to work on Marlin.
Sure. So Marlon, I mean, to be honest, I was doing product management throughout my life. I started in Web2. I built a bunch of consumer products, both global as well as regional, predominantly within the food tech as well as fintech space. And then I was curious about the whole AI space, right? And that's when I came across Marlin. And then they were doing pretty cool stuff with the T's and everything. Um, they were building the most essential missing piece of the puzzle, which is a confidential computing layer. That's how I gotten involved with Marlin. So I started contributing to them while I had my Web2 job because, like everyone else in Web2, I was also skeptical with Web3. So I was trying to learn a bit more about the whole product, the team, and that's how I gotten involved over a period of time. And after joining, there is no looking back. We have been building some cool products, enhancing developer experience throughout. So yeah.
Mhm. Great. So, actually, Marlin has been in the industry for several years, and I'm curious about its growth and evolution. Could you take us back to its beginnings and give us a brief tour of its journey?
Yeah, for sure. Marlon's journey actually started in a very different place than where we are today. So today we consider Marlin as more of a confidential computing layer for AI as well as DSI. But when we started way back in the day, it started as a open source project focused on making blockchains faster. That was the whole idea behind Marlin. Specifically, we were optimizing the networking layer, the peer-to-peer communication between the nodes, so that the transactions and blocks uh, can be finalized faster. So that was the initial journey. And then one area where the speed really mattered was MEV, or as everyone calls it, maximal extractable value. And within this MEV space, the searchers, the folks who tried to profit from transaction ordering, needed to get this information and send the bundles of transactions super fast, right? And what we were building were pretty much lead to as a use case of what searchers were looking for. And this led us to think, how could we let the searcher deploy their trading strategies as close as possible to the block producers, the one actually creating the blocks. Those are called the block producers. But they had couple of key requirements, right, to start using the technology. One is the strategies had to run super fast and as intended. So there has to be a certain layer of verifiability aspect of it. And the second thing is the strategy has to be private. No one could see the strategy. If they see the strategy, someone can front run you. So the whole idea is it has to be verifiable as well as it has to be private in nature. So that what got us into looking for confidential computing techniques and specifically T's and ZKPs. So yeah, the whole idea started from practicality for speed, security, and then we ventured into the whole T and ZK space.
That sounds a very natural extension. So, I also remember in the early days, Marlin was one of the key players in this concept called Layer Zero, um, among
Yeah.
several other players. So I'm curious, how did its development progress after 2019?
Okay, so the term layer zero itself is honestly pretty vague, right?
Yes.
There is no universally agreed upon single definition, and everyone used it as they seemed fit. And when we used it at Marlin, the term layer zero, we were specifically talking about the network layer optimizations, right? Think of this: network layer is the foundational layer for peer-to-peer communication, and it's pretty much invisible, right? You can't see it, but generally you don't talk about it, but it is the most foundational important layer, because ultimately your transactions and everything needs that peer-to-peer networking and communication. That's why we also chose the name Marlin, because it is the fastest fish in the water, and it's invisible, similar to the whole networking layer, but it is essential, and it has to be fastest, and it's all about the speed. It is also important to highlight that layer term has gone in different directions, right? The layer zero term, Cosmos used it in a different way. Then you have layer zero using it in a different way and building different use cases altogether, right? But while we may all have used it at some point, but we were all building different problems and different use cases. So there is no universally agreed upon definition for layer zero.
Cool. Thanks for sharing that. It's always quite interesting to look back to the
Yeah.
early days and some like the concepts that popular at that time. Yeah. So it seems that 2024 was an important turning point for Marlin. You launched two main products, Calypso and Oyster. So we'd love to learn more about both of them. So maybe we can start with Calypso first. Can you tell us more about it?
Yeah, for sure. Just a correction, we did launch Oyster way back in 2023. Calypso is something that we launched in 2024. Um, so Calypso is a ZK-proof marketplace. The whole idea behind Calypso is, if you want to generate ZK proofs today, those are still compute intensive. You won't be able to generate them on your user devices like your laptop or your phone. And it requires certain kind of specialized hardware, right? So there are two ways to go about it: either the protocols or the developers who are building that specific ZK circuit, they can procure that said specialized hardware and outsource the hardware generation. But the issue with it is it leads to a centralized solution, right? And the second thing is the cost of procuring this said hardware is very expensive. It's not easy, and the maintenance is also a challenge. So for the developers, they would rather focus on what they are building, the use case, rather than focusing on one specific solution of generating the ZK proof. So that's where Calypso comes into picture. So it's a ZK proof marketplace. We built it as a AVS on top of Symbiotic. So you get the economic security as well from the Symbiotic ecosystem, and we have a diverse set of hardware operators on the network. So you can outsource any sort of proof generation, and the proof generation goes through, uh, gets assigned to a bunch of operators. So the matching itself happens in ATE. So we use the order book based exchange design, wherein the matching of the proof request happens to a said operator in ATE, so that there is verifiability as well. And yeah, that's how Calypso operates. One way Calypso differentiates compared to other ZK proof marketplaces is the capability to support private inputs. For example, if you are working with some sort of sensitive information, say I'm using Omar's personal identity information, I don't want to reveal this to anybody in the network. So there is a capability of generating the said ZK proof in a TE, wherein the inputs are also not exposed to anyone in the network. Uh, while you may say that pretty much all the proving networks are doing something very similar, ultimately it's a supply demand kind of a matching. But the way we differentiate ourselves is with respect to supporting the whole private inputs as well as ensuring that you have a verifiability throughout the supply chain of generating the ZK proof.
Yeah, I'm curious about the current participants on both the supply and the demand sides on Calypso.
Yeah, for sure. So right now, we have a couple of markets which are currently live. So the first market is a AI agent verification market. So whenever you run an AI agent in a team, you would get something called as attestation certificate. So you can take this attestation certificate and then verify it directly on chain. But the required gas fee to verify directly on chain is to the tune of 75 to 80 million gas, right? The alternate approach is you take this attestation certificate, you generate a ZK proof out of it, and then you verify the said ZK proof on chain, right? This approach reduces the overall gas fee to roughly 250K to 300K gas fee, right? So that's about a 200x reduction in overall gas fee, which ensures that as a developer you can verify more and more attestations rather than attesting one or two, right? So that is one of the markets which is currently live. And the other one that we have is about supporting Noir circuits. So as you can see, Noir circuits are one of the important innovations within the space. It's pretty easy to use. Builders have been using it quite extensively to build some novel applications. But uh, every time generating ZK proofs themselves is a headache for the builders. So they have an option of outsourcing that to Kalypso marketplace. So wherein we have a capability of generating the said ZK proof in ATE. So these are a couple of interesting use cases that Calypso solves from a demand point of view. On the supply side, we pretty much work with operators like P2P, Kiln, Instones, and the likes of others. Thanks to the symbiotic integration, it unlocks a wide set of operator network for us with a diverse set of hardware as well.
So you just mentioned this NOR case. I'm curious then, by maybe collaborating with Calypso that can help Aztec to decentralize their prover.
Yeah, I mean, there are a couple of use cases, right? One is Noir in itself; it's a circuit in itself, and then we have a option of supporting builders who are using Noir. That's one. The second thing that you're talking about is the overall decentralized prover network that Aztec is working towards, right? So Aztec, the way Aztec works, as you are aware, they are a privacy centric ZK rollup, right? And they want to have everything decentralized from day one. So that means the whole proving also has to be decentralized, the sequencing also has to be decentralized. And every block that gets submitted on the final Ethereum chain needs to have a ZK proof attached in order to advance the chain, right? So that's how Aztec works. And then one of the things that they are focusing on is the decentralized prover network, and we did participate in the Aztec ProverNet that happened last year, and we had like stellar results. We pretty much submitted all the blocks that they shared with us. We proved pretty much all the blocks, and we had a average time of about 6.5 minutes per block. That is again the very first ProverNet. We are currently focusing on running sequencers and also provers for them for the next iteration of ProverNet. So that's what we have been working on the Aztec front.
So just to get it straight, in the context of Calypso, the TE and ZK are two options offering the same, are interchangeable, right?
So the offering is still the ZK proof generation. You have the capability of generating ZK proof standalone. That's one, wherein if you are working with public inputs, you don't have to go for a TE based option. But if you're working with some sensitive data that you don't want to expose to the network, you have an option of generating the ZK proof in a TE. So that's what we offer. And the matching of this set request itself happens in a TE. So TE is used at two places. One for the matching of the said request with the operators or the hardware providers. That's one. And the second thing is you have a capability of generating a ZK proof in a TE as well.
For that you use which TEs?
So currently what we support is Nitro enclaves, but we are soon adding support for additional TE varieties like Intel TDX as well as AMD. So those are all on the roadmap.
So you can basically take any ZK protocol, let's say RISC-0, and add privacy to it with TE technology, correct?
Yeah, pretty much you can say so. I mean, we did also run the whole SP1 as well as RISC 0 in ATE. In fact, Omar, you mentioned RISC 0. RISC 0 is what we use currently today to generate the overall ZK proof for AI agent verification. And we did run SP1 as well in ATE. So it's all about whatever circuit that you are working with, and if you want to ensure that specific circuit uh, has some private inputs that you don't want to expose, we can add T as a additional capability. And the best part is all of this is in production. So that is the best part, so anyone can start using them.
What were the reactions you got from your customers or the community for TE? Did you get more of endorsement or pushbacks on incorporating this technology in your product?
Mostly positive. Uh, Obviously, there are certain specific use cases. Even with Alio, we work with Alio as well closely. They are focusing on privacy as a core component of their blockchain. So some of the dApps that are being built on Alio, they want the proof generation to be done in a privacy preserving manner, and that's where TEs comes in picture. uh, as you are aware, Aztec is another use case, Noir is another use case, right? So overall there is a positive feedback from the community. Obviously there are also certain level of apprehension towards TEs. Basically people who have had bad experiences in the past with Intel SGX and the side channel attacks, they tend to sort of uh, say that should we even trust TEs? So my counter question to that is, if you are trusting your devices that you own, I think it's safe to say that you can trust a TE. But at a overall level, I think this is something that some of the community members were looking for, some of the builders were looking for, and they are actively using it at this point.
Who else is using TE in the space? Is there a competition here for companies that specialize in utilizing TEs for certain applications like adding privacy in Web3, for example? Are you working, are you collaborating with some of these other companies? Or like, did you build it from the ground up, the T stack, or did you use one of the off-the-shelf or existing stack from someone else?
Yeah, so far we spoke about Calypso. If we are going into the TE space, I can share a bit more about what exactly we are doing on the TE front. So we have something called as Oyster. It's Marlin's framework to make super easy for builders to build and deploy applications that can run in a TE. So think of like this, right? If you can build a Docker image, you can use TE. As simple as that. So any sort of code that a developer can Dockerize, they can use inside of a TE, and it handles all the complicated stuff like networking, verifying attestations, managing keys, so that developers don't have to become experts at running TEs overnight, right? And Uh, just touching upon what Omar spoke of, in case of Oyster, yes, there were TE based blockchains like Secret, OSS. Fala also allowed FAT contracts to be deployed on Intel SGX machines, and but all of them had their own blockchains again, right? There were also attestation verification services by Automata, but there was no single framework which made it simple to run backend applications to be deployed in TEs. And a framework that can work simply with any other blockchain, right? So hence we coined the term TE-based co-processors with Oyster, since we allowed developers to deploy any sort of applications. Those can be like AI models, those can be end-to-end backend services. They can deploy it to TEs and even pay and interact solely through smart contracts, um, without going for any other solution, right? So that's how it started. And there was also, I don't believe there was any offering like Marlin Hub for over a year, wherein you can provision any kind of a server, and we are the only uh, provider even now in the space who provide serverless as a capability. So we provide within Oyster, there are a couple of capabilities. One is CVM, which is your confidential VM, wherein you uh, get the whole instance rented out. And the other one is a serverless capability, wherein you can pay as you go, and you can have a shared instance with others as well, right? So I don't think there was any other offering like that for over a year, since 2023, since we launched. Until recently, Fala, I believe, launched Fala Cloud. And even now, among other coprocessor based applications where TE requests are to be accepted and where the compute happens off chain, either through a relay contract or through a smart chain, and where the results are shared back on chain, I believe Marlin offers the best support among all other frameworks out there. And just in terms of other frameworks out there, I believe there is Marlin's Oyster, and the second one is Flashbot and Fala. They built something called as D-Stack in collaboration. I don't think there are any alternatives as such, and we have built all of this grounds up, right? Um, yes, we do interact with other projects in the space, but that's mostly around bouncing off some ideas. How can we educate builders and developers more about TEs? I mean, just to give you an example, uh, in EAT Denver 2024, no one knows what TEs are. When I spoke about TEs, people were asking, okay, are you talking about t-shirts or merchandising? Are you trying to sell us merchandising? Right? From that, in 2025, when we had a TE event, it was houseful, right? So we had people waiting to learn more about these. We had people asking questions about, hey, how are you doing key management? How can my AI agent be fully autonomous with the help of these, right? So we have come a long way, and that is thanks to the collaboration with everyone within the space, right? So we did a bunch of education over a period of like 1 to 2 years, which right now is helping us to advance the space. So yeah, we do collaborate, but mostly on educating builders and trying to figure out how can we uh, introduce novel concepts. So that's the idea.
Probably also thanks to AI.
Yeah, obviously, I think since you have touched on AI, I mean, I think AI did help a lot when it comes to the adoption of TEs, right? Even the whole PCC announcement by Apple also helped us. So PCC is private cloud compute, but the underlying technology being used by Apple is TEs. So they announced that anything that is not happening, the compute which is not happening on the device is happening in PCC or a secure enclave, right? So that has helped us quite a bit, right? And with AI, especially, imagine this, right? So late 2022, ChatGPT dropped. their very first announcement, and everyone went bonkers, right? Everyone is blown away by what AI can do. I mean, people started what used to take people like few hours is taking like few seconds, or few days is now cutting down into like few hours. So everyone was blown away by it, and naturally, like everything else, the crypto community started figuring out, okay, what are the drawbacks, how can we make it more sustainable, more verifiable. So blockchain and crypto community always acted like more of like the governance layer, while AI acting as the intelligence layer. So we ventured on to figuring out, okay, how can we make the AI actually verifiable? How can we make sure what AI is giving us as results is what it is supposed to be? How can we trust it? How can we verify that the actions are not going to be against me over a long period of time, right? And then there were a bunch of techniques that people started figuring out, right? The whole space is called verifiable computing. People started venturing into, okay, can we use ZKML? Can we use FHE or MPC, right? But the problem turned out to be the performance, because AI models needs performance, and they also need heavy computational resources, which was a bottleneck with, say, ZKML as well as FHE, because FHE is super slow, ZKML was slow. There was a report by a certain crypto project wherein they spoke about, to generate $1 of inferencing, it used to cost about $118, right? So no one is going to pay 118 times, right? And MPC had its own drawbacks, right? That's where Teas, on the other hand, was a already available solution. It's widely accepted. Uh, your phone has Teas. That's why you store sensitive information like your Face ID or your uh, tokenized payment data, right? That's why you never hear that so many biometrics or so many Face IDs have been leaked. We never hear that, because those are stored away in a secure environment that even the hardware manufacturer can't access it. So Ts were widely available. They were widely being used even in case of Web2, healthcare, defense uses them. So it's pretty natural fit for what was happening. The best part is the overall overheads, right? For developers, they don't have to learn entirely new technology, especially if you are a AI developer who is pretty much familiar with Python or Rust. Yeah, pretty much that's what you have done throughout your life. Now if you ask them that you have to learn blockchain as well, or you have to figure out what circuit works and what doesn't work in case of ZK and stuff, it becomes more of like a challenge for them. But with Ts, they don't have to go through all of that learning curve. Even the cost, when it comes to Ts, it's the overhead is very minimal. It goes anywhere between 10 to 30% compared to ZK overhead, where it is about anywhere to the tune of like 100 to 200x, right? So all of those things sort of helped to advance Ts within the space.
Cool. It's interesting to see that you actually conducted a benchmarking between Oyster and ZKML. So could you share the reasoning? I think you've mentioned several
Yeah.
behind the comparison and also how it went.
Yeah, for sure. So while we know that Tees is a very good fit, most builders weren't even aware. Like I previously said, in ETH Denver 2024, people didn't know what Tees are. So we at ETH Denver, we unveiled a new concept called TEML. It's basically an equivalent to ZKML. That sort of wherein we showcased how the benchmarks will look like at a high level when it comes to cost, when it comes to speed, and when it comes to flexibility, especially in case of AI models. So that did trigger a lot of interest among builders, but they were still curious to learn, and they were still hesitant to adopt to it because they want to see the performance, right? Okay, you are saying that this is faster, but how faster, right? and whether it's going to be cheaper or whether it's going to be same price. That is also another thing that the builders wanted to know. That's why we put together those benchmarks. So what we did was we did a small benchmarking activity of different models and different circuits between ZKML and TEML. The performance was like TML is few orders of magnitude faster compared to ZKML. For example, it's at least like few like 100x to 500x faster compared to ZKML. So that is what the overall benchmarking came out to be. And the second thing is the pricing was like on an average came out to be 18% more expensive compared to your traditional cloud compute. So these two benchmarks sort of helped us to build confidence and demonstrate that both TML and Ts are a very good fit to build practical solutions as well as bringing the verifiable AI to life. So that's the idea behind it.
Cool. Are there any other interesting use cases on Oyster now, except for AI use case?
Yeah, decentralized front ends is a pretty good use case that we have been working on. So we collaborated with 3DNS for this. I mean, the most fundamental challenge that we see from time to time within the DeFi space is the front ends getting compromised, right? And this compromises leads to massive loss of funds, massive loss of users not being able to access the front ends. It creates a mistrust among users and everything. So decentralized front ends came out to be one of the solutions. The way it functions is you as a entity or a DAO, you verify your code and you sort of make this code open source in nature, and you publish the Docker file along with the hashes, right? So the code hash will be identified by a specific T so that you can access it, right? So that is a very specific use case that we have been working on, and we collaborated with the likes of 3DNS, where you can also manage your domain on chain completely. That is very interesting use case. And the second one is about running low latency order book based exchanges. So we have a couple of teams building the whole Dexus in a T, and one of the challenges that they have is if at all if the T due to whatever reason crashes, the unfulfilled orders and everything will be lost, and that will be a disaster. Hence, we built the whole key management system also around it. So these are a couple of very critical use cases where we can unlock value immediately for end users with the help of TEs.
So you guys at Marlin also wrote one of the more critical write-ups on TEs and like with guidelines and such. Um, we've been talking for some time now on the benefits of TEs, but maybe you can also share more about the risks um, and
Yeah.
how do you complement it, let's say, with cryptography or what mitigations you guys are looking into.
Yeah, for sure. So when it comes to the shortcomings, there are quite a few, right? So one is basically you have to trust the hardware provider. In this case, either AWS or Intel or AMD. So these are the ones who are providing the hardware. So uh, you have to trust that they will act. They won't act maliciously, and uh, they wouldn't want to go to crypto users to back channel some of the data or whatever, right? So that is one thing. But again, one of the workarounds for you to circumvent this is you have a spread of different kinds of TEs, right? So you have a TE by AWS and a TE by Intel and a TE by AMD. So you have something called as multi-TE ecosystem that will ensure that there is no single root of trust, and the root of trust changes with each and every hardware provider. That's one. Even there is something called as OpenTE design, which is currently being developed by a bunch of folks within the space. The problem is the current TE design is pretty much closed space, right? It is designed by the likes of Intel or AMD or AWS, and they haven't shared it open source, right? So no one knows how the, I mean, people know how the root of trust works, but given that the design itself is closed, people didn't know much about how the hardware is constructed and everything. So there is a whole OpenTE initiative which is talking about open sourcing the hardware design as well. So that will also remove some of the shortcomings of this specific TEs. The second one is Intel SGX had some vulnerabilities in the past. They had side channel attacks and stuff, but that again can be mitigated by running your servers in kind of a on cloud or data centers, right? If you don't have physical access to a TE, you won't be able to extract the teas or anything, right? That is the second approach. Even Intel TDX, the next version of teas that are developed, they also circumvent some of these issues, right? If you consider these two as one of the, I mean, these are some of the issues. The other ones are also with respect to the reproducibility, right? How can you reproduce that the code always results in the same binary whenever there are no changes? So we built something called as blue images specifically for this, which gives you some kind of a auditable base version of the code as well, right? So at a high level, we did build solutions around some of the issues that have been cropped up in the past couple of years. Uh, the fourth one that I previously touched upon is T's being if T's crashes, the data being lost, or the AI agents won't be able to access their wallets, or the exchanges losing their unfulfilled orders and all of those things. So for that, we also built a secure key management system wherein the key generated is split across 30 different nodes. So we implemented a split of T as well as MPC, wherein the key is not accessed by one specific node per se, it's split across 30 nodes, and you just need 16 out of the 30 to be available to you for you to reconstruct the enclave again, right? So at a high level, if you look at this, T's are more of like water. They can coexist with any of other cryptographic techniques as well, right? T's can go with ZK as well. That's what we have been doing in case of Kalypso, wherein we generate a ZK proof in a T. With our key management service, we do use a bit of MPC along with T's to ensure that the key is split across multiple nodes and the recovery can happen when you have like 16 out of the 30 nodes, right? It can also coexist with something like your FHE as well, wherein the data which is generated at the source level, you can still compute it in a TE so that no one can see what kind of a data that you are working with. So I think it coexists very well with any sort of cryptographic technique. And with some of the shortcomings that have been discussed, there are alternatives or there are guardrails in place to avoid them at this point.
So for attestation, you need open source code. Is your code fully open source?
Yeah.
Okay. Is there anything you do to reduce the complexity of the code? I mean, to make it easier for auditing purposes?
Yeah, so what we have done is we came up with something called as blue images. So there are like couple of things, right? So one is the whole building the image part of it, and the second thing is or building the Docker image part of it, and the second thing is the actual application deployment itself. So what we did with the blue images is it's more of like sandboxed environment where we prepare certain templates that can give certain guarantees, like the enclave has no networking access, or it will have no file system access, or only certain networking endpoints can access this enclave. So we will give you certain guarantees to that specific sandbox environment. So with that specific sandbox environment, any kind of TE applications which are built will have guarantees that, okay, this specific Docker image or this specific application will already have ABCD already predefined with it, so that you don't have to go ahead and again audit that specific code, and you are just focusing on whatever the front end that is built on top of it. So for developers, it will reduce the overall time to go to market, and it will also reduce the overall auditing requirements as well.
So I have one last question
Yeah.
for you, Esli, because I can tell how excited you are, like talking about AI. So would love to hear more from you. So how do you see the crypto AI trend evolving in the near future, and what role will Marlin play in shaping it?
Yeah, for sure. Like I said earlier, I think AI as the intelligence layer. So it's what makes everything smart and then provides insights. It can look into complex data, give you insights. It can replicate the redundant work for you at scale. Blockchain, on the other hand, it's more of like governance layer. It provides trust, which is the most important thing that a end user looks for, making sure that everything happens the way it should happen. Because of this trust, it also unlocks a lot of end user use cases, right? Ultimately, with crypto cross AI, I think today, if you look at AI, you have a bunch of four large buckets. So one, you have the compute, one, you have data, which goes in building the foundational models. Then you have the training, which trains on this specific data. Then you have the compute layer, and the final one is the inferencing, right? So you have four broader sections. uh, what we are seeing right now is all of these components are pretty much centralized today, or managed by central entities. But what we are seeing is some of this components are moving to Web3 solutions. And over a period of time, the true decentralized AI will happen only when all the components will become decentralized. That means your data is also outsourced in a decentralized and verifiable manner. You can figure out where this data is originated from, and it's not synthetic data, it is user owned data. For example, in case of AI models, data is the most important thing. It is the foundational thing, uh, which ensures the quality of the output. But as we know, AI models have exhausted all the public data available to them today, right? So now they want private data. So people are doing synthetic data generation using that data, but obviously synthetic data won't be equivalent to what you and I experience in our day-to-day lives. So you want something like user owned personal data or private data, but uh, users won't be able to share the data to anybody, right? So that's where blockchain comes into picture. There are projects like Vana which are dealing with this specific issue, right? Wherein they let anybody to contribute their data to blockchain, and they also ensure that they get paid when the data is used. So I think that's pretty cool. What this also unlocks is the foundational models will get better and better with the higher quality of data. Now, that is one part of the puzzle. No, now going back to the next one, it's not only about sharing this data, right? You also have to use this securely. You won't be able to. You want your AI models to use this data without sharing it with anybody else, even the AI provider themselves, right? If I'm a developer, how would you want, you as an end user, you want to ensure that even the AI developer won't look into your data or won't steal your data. So that's where verifiable computing comes in, and TEs or trusted execution environments, they are a very fantastic option for that, right? They provide isolated environment for computation. Similarly, in case of inferencing as well, TEs provide what kind of verifiability, what kind of AI model has been used. You would be able to know that the AI model used is actually what it is supposed to be and not something random. So I think the subcomponents will also get truly decentralized. That's one. And if you look at Marlin's overall positioning, we see ourselves as the enabler, right? We provide the platform and the tools for developers to build reliable applications which are verifiable, which are secure. We have teams building like personalized AI assistants, or there are also solutions wherein there are healthcare solutions that are currently being built and wherein you can outsource, you can, sorry, not outsource, you can uh, crowdsource a lot of patients' data and get insights out of it, and without anyone seeing in terms of what the data is about. So yeah, ultimately we want to be the enabler and we want to make it easier for developers to work with Ts. So yeah, we will be that secure and verifiable computation powerhouse for builders.
Sounds very ambitious.
Yeah, we
Best
have to
of
be.
luck. Yeah, so before we wrap up, we have a routine question, a very
Yeah.
quick one for you. So please name a project you're bullish on.
I'm pretty excited about Aztec, to be honest. I'm actually looking forward to their mainnet. The kind of use cases that it will unlock is phenomenal. So that is one project that I've been looking forward to.
Cool. Seems you're the second guest on the show that mentioned Aztec. So I guess Aztec should be on the show very soon.
Yeah.
Okay,
Cool.
thank you, Esli. Thank you so much for joining us today. It was great to learn about Marlin. And for those interested to learn more, we've added some links in the show notes. Thank you, Omar, for co hosting with me.
Thank you, Queenie.
Thank you.
Thank you, Queenie. Thanks, Amar. Thanks for your time. It was fun having this conversation.